I'm Anil Kumar, and in this video we'll try to understand transformation of trigonometric function, specifically tangent of a function. Now the tan function is kind of typical since it has vertical asymptotes and unrestricted range. It has a restricted domain. So the question here is, question number 3, state characteristics of y equals to 2 tan half x. So before getting into the transformed function, let us sketch the function tan function itself, right? And then we'll write down the characteristics of the transformed function also. So as I was saying, tan x has vertical asymptotes, and these vertical asymptotes are at plus and minus pi by 2, plus and minus 3 pi by 2, plus and minus 5 pi by 2, and so on, right? So, and the time period for the tan function is pi, not 2 pi. So that is how tan x is very different from sine and cosine x, right? So let me sketch one here, and then we will discuss the characteristics of this function. So tan function, as you know, is kind of like this. It is always increasing in its domain, right? So it's kind of like this. So it is increasing with 0 at the center and then the asymptotes on the side like this, right? So that is how the tan function is, right? Now what I've drawn here is tan x. We'll be talking about tan of half x in a minute. So this is a function. Let me write here tan x, where this is 0. These are pi by 2. Asymptotes are pi by 2 and minus pi by 2, or 3 pi by 2 minus 3 pi by 2. So as you can see, if you start from 0, for example, then the function actually is 0, and this next 0 comes at pi. So it repeats after every pi. So the time period for tan function is, so let me write down here, time period is pi, and we know vertical asymptotes for this function are at x equals to plus minus, let me write half pi by 2, or plus minus 3 pi by 2, so on. In general, we can write this as 2n plus 1, since these are odd multiples of pi by 2. Is that okay? So that is how we can write, and this is minus pi, zeros. So on the even multiples or of pi by 2, we should say that the zeros for the function are at, you can see, 0, plus minus pi, plus minus 2 pi, and so on. So we can say n pi will give you zeros for the function where n belongs to integers, right? So that is in general for, I should say, tan function, right? The primary trigonometric ratio tan. So let's keep it out for some time, but we will take help from here to answer these questions. And I hope my reason for making this video is, since I wanted to relate the two, I thought there are already so many videos, but let me do it this way. Now let's look into the equation, which is y equals to 2 times tan of half x, right? We want to know what is the period. As you can see here, it is horizontally stretched by a factor of 2, right? So when you horizontally stretch, all these numbers on the x-axis will get multiplied by 2, right? Therefore, the time period will be, pi is the original time period. As we have seen, it gets multiplied by 2, and we can say time period t equals to 2 pi, right? It is no more pi. For half of x, it is 2 pi. Vertical asymptotes. So we have general expression for vertical asymptotes here. So vertical asymptotes, as you can see, for tan x will be at plus minus pi by 2, plus minus 3 pi by 2. But since horizontally it is stretched by a factor of 2, vertical asymptotes will be at x equals to 2 times 2n plus 1 pi by 2. Do you see? So 2 and 2 cancel. So it is pi times 2n plus 1. That is to say that now these vertical asymptotes will not be at pi by 2 plus minus, but they'll be at plus minus pi, right? So like that. So plus minus 3 pi and so on. So that is how the vertical asymptote's position is going to change. Since the function is horizontally stretched by a factor of 2. Zeros were at n pi, correct? So they will get stretched to the even values of pi, right? So the zeros will be, instead of n pi, the zeros will be 2n pi, right? So the zeros will be at x equals to, not at, so 0 of course, right? 0 get multiplied and gets 0, but pi will become 2 pi. So plus minus 2 pi, plus minus 4 pi, and so on, right? So that's the general expression where n is an integer, right? Now domain for this function is that it should include everything except for the vertical asymptotes. So we can say domain is x belongs to real numbers where x is not equal to position of vertical asymptotes, which is, we can say 2n plus 1 times pi. Do you see that? So that is how domain is changed. But the range, you can see, is from negative infinity to positive infinity. So y belongs to real numbers. Axis. Tan x does have an axis, and that's kind of important characteristics which you should consider. It is y equals to 0. Since in this equation we are not transforming it or translating it up and down, y equals to 0. If you translate it up and down, this axis will change, right? I have purposely not translated. The reason being, then it becomes very difficult for me to calculate the zeros, right? So that's the reason why I didn't translate it in this particular equation. But I think with this example, you get the whole picture of transformed tan function. I hope that helps. I'm Anil Kumar. You can subscribe and learn a lot more from my videos. Thank you and all the best.